Wonderful, wonderful. It's a beautiful day. Welcome to another lesson video. Today we are going to look at a very interesting topic, which is geometric progression. Now, how to find the sum to infinity of a geometric progression. The sum to infinity. So, ladies and gentlemen, this is the last topic. This is the last concept we shall look at under sequence and series. So, I ask you to pay particular attention and be able to answer simple questions as they come. Let's begin. The sum to infinity. Sum to infinity of the geometric progression, okay? Of the geometric progression. The sum to infinity is calculated on a geometric progression with an infinite number of terms. So we are simply saying the sum of to infinity is calculated on geometric progression with an infinite number of terms. Infinity simply means that terms that don't end. They continue going. They never end. They have no ending. Now, for you to calculate such kind of a sum, you need to be able to use a certain formula that we use. And this formula, it is simply given by sum to infinity. Like you can see, this is a crazy 8 somehow like looking like. Sum to infinity is equal to first term over 1 minus r, that's all. Where r, which is the common ratio, is less than 1. Now, sum to infinity, we are only going to calculate sum to infinity if the common ratio is less than 1. If it's greater than 1, then you cannot find the sum to infinity. You can't. So keep that in mind. So this is the formula we are going to use in order to find the sum to infinity. So make sure that you know this formula by heart. You don't forget it. Let's look at the example without wasting a lot of time. Let's look at the example. Find the sum to infinity of the GP 421. So this is an infinity geometric progression terms. It continues going. So how do we find the sum to infinity for this one? Now, as if that is not enough, we shall look at another 20, I think this is a 2019 past paper. This is a 2019 past paper. We shall look at the 2019 paper 2, okay? This is 2019 paper 2, grade 12 paper, okay? So, and it carries 7 marks. So now let's see how this question is done. They are simply asking us that in a geometric progression, the third term is 16 and the fifth term is 4. Calculate the first term and the common ratio. The 10th term, the sum to infinity. Okay, we are calculating the sum to infinity. So the big deal here is on how to find the first term. That's a big deal. So before we look at this thing, let us look at how to find the sum to infinity. So question number 1, solutions. Okay, let us write solutions here. Question number 1, they're asking us to find the sum to infinity when you're given the geometric progression terms to be 4, 2, 1, and so on and so forth. So we need to find the sum to infinity for that kind of a geometric progression. So let us write the formula. The formula is sum to infinity, we write a close 8 there, is equal to first term over 1 minus common ratio. Now, what is it that we don't know on this formula? Let me just write data here. Okay, data so that you see what is there and what is not. My first term, do I know my first term? This A stands for first term. My first term is equal to 4, correct? What about my common ratio? These are the only thing I need to find. The common ratio, I don't know. So I need to find the common ratio. How do I find the common ratio? By simply using the formula. Common ratio is equal to term 2 divided by term 1. So what is my term 2? My term 2 is 2. My term 1 is 4. What will be my final answer? 1 over 2. That is the common ratio, which is 0.5. And now this common ratio, it is less than 1. Okay, so you can find the sum to infinity. But if it was greater than 1, you could not have used this formula to solve the sum to infinity. So the common ratio should always be less than 1 to find the sum to infinity. So 1 over 2, or you can say 0.5. The sum to infinity is less than 1, hence you can find the sum to infinity. The ratio is less than 1, hence you can find the sum to infinity. Now let's work it out. So we are simply saying sum to infinity is equal to, what is my first term? 4 over 1 minus half. Okay, now bear in mind that this one you have to use a calculator, because this is a paper 2 question. So a calculator is very important. You need to be able to use one so that you find your working easy. So how do I work out this one? I'm going to work out this one by simply writing this in a decimal form and now use a calculator. So we are going to say sum to infinity. Instead of writing 1.5, half there, let me write 0.5. 0.5. Then I can subtract this by simply saying 1 minus 0.5, because I have a calculator. It means that I have equal to 4, 0.5. Now 0.5 here, if you want, using a calculator, you can go ahead and do your punching. 4 divided by 0.5, you are going to get your answer 8. Or if you want, you can now write it in this manner and just say 1 over 2. So this one now, we work it out as 4 multiplied by 2 over 1. Our final answer will be 8. So sum to infinity is equal to 8. So sum to infinity for this first part, it will be what? It will be 8. You have found your sum to infinity using this course formula. And you are done. Simple. No wonder it's too much. A calculator, you use a calculator to make your work easy and to work with time. Remember, don't pretend to be too smart when you know that you are going to waste a lot of time. Use your calculator to work out things quickly and fast. Okay, so you have here your answer. Sum to infinity is equal to 8. Okay, so the first thing you need to do is to find the common ratio. When you find the common ratio, hence you can find the sum to infinity. Now let's look at this question. Let's look at this question, which is question 2. Question 2 now. So the key here is the common ratio and the first term. If you don't know the common ratio and the first term, even if they give you 5th term or 7th term, you cannot find the sum to infinity. You need to first find the first term and the common ratio. So let us see how we can work out this one here. So we start with question 2. This is the question 2, Roman numeral 1. So Roman numeral 1, they are asking us that we should find the first term. The first term and the common ratio. So we need to find the first term and the common ratio. Therefore, we can find the sum to infinity. If you don't know the first term and the common ratio, then just know that you have gotten your answers wrong and your 7 marks is wasted. So this one is a challenging one. So, but this was straightforward, but this is a challenging one. So let us see how we can work out this one. So let us write the formula for finding the terms. The formula for finding, we need to find the first term. So the formula for finding the terms, we have A1, or the nth term, is equal to A R n minus 1. That is the formula for finding any term, isn't it? That's the formula. So now we want to find the first term. Remember, you can find the first term if you know the common ratio. Now we don't know the common ratio, so how can we find the first term? Let us list the concept here. They are telling us that in the geometric progression, the third term, so the third term is what? 16. And the fifth term is 4. Calculate the first term. So they have given you the third and the fifth term. So meaning that you have these terms. Let me list them down here. Term 1, I don't know. Okay. Do I know term 2? I don't know. But term 3, the third term, they have given me to be 16. And term 4, I don't know what term 4 is. Okay. But term 5, I know which is 4. These are the terms they have given me. They have given me there. Now they want me to find the first term, which I don't know. And now when I don't know the first term, I cannot find. So I need to use what I've been given in order for me to come up with the answer. So we are going to use these two terms that I know to find the common ratio. So how are we going to use them? We are going to use the same formula to find the common ratio there. So let's start with writing the term. This is term 3. So we know term 3, so we are going to say term 3 is equal to, what is term 3? A1, we don't know what my first term is. And my common ratio I don't know, but my n I know, it is 3 minus 1. Okay, so I simplify. What is my third term? Third term is 16. So it will be 16 is equal to A1 R to power 2 when I subtract that. So this now, it will become my first equation. So I'll write this as my first what? Equation. You find the first equation. So find another equation for 4 for the fifth term. So using the same formula, we need to find the fifth term now. The fifth term of this one, we have A1, I don't know, common ratio, but the n power I know, n minus 1. Let me write the formula there. So fifth term is what? Fifth term is 4 equal to A1 I don't know, R I don't know, n I know, which is 4, because they're asking me, it's not 4, but the fifth term is 5 minus 1. Okay, so now we continue. 4 is equal to A1 R to power 4. This is my second equation. We have two equations there. Now when you have two equations, now you have to solve them. You can solve them simultaneously to find the value of the common ratio, or you can solve them the way I'll show you to find the common ratio. So let us solve them. We start with the second term. We start the second equation. We are going to say the second equation is 4. Let's write it in this manner. A1 R to power 4 is equal to 4. Then the third equation, the first equation is A1 R to power 2 is equal to what? Is equal to 16. Now, to solve this one, we need to divide. Okay, we are going to divide this part, these two. We will divide these two and also these two. So we are going to say, when we divide these two, and this side we are going to divide here. So we need to find this part. Now we know that this and this, they are the same. So we are going to divide them and we cancel them like that. We remove them. We divide them, we have 1. Now R to the power 2 and R to the power 4, they are not the same, they are different. So you cannot cancel them. So instead here, we are going to maintain the base using indices law. We are going to maintain the base and subtract the powers. Maintain the base and subtract the powers. So we are going to say, what is 4 minus 2? So we are maintaining the base, which is R. Then 4 minus 2 is equal to 4 over 16. We don't do anything this side. Work out this side first. So we are going to have now R to the power 2 is equal to 4 over 16. Okay, now how do I get rid of the square root on the part of R so that I make R the subject of formula, and that will be our common difference? I square root both sides. I introduce the square root. So if I introduce the square root on both sides, I'll have the square root this side and this side. So that this and this, they can cancel each other. Then I have common difference. Now I have, what's the square root of 4? What is that number when you multiply it 2 times you get 4? That is 2. So we have 2 over square root of 16, that is 4. So the final answer for the common difference now, common ratio, it will be 1 over 2. 1 over 2, that's a common ratio. Have you seen how we have found the common ratio? 1 over 2. So that is how you find the common ratio. We have found the common ratio, hence now we can go ahead and find the first term. Because if without the common ratio, you cannot find the first term. You need to know the common ratio for you to be able to find the first term. So the only way you find the common ratio is by using this formula. You cannot use this other formula which we used here to find the common ratio, because you don't know the first term, neither the second, neither the third, neither the fourth. You don't know. So this is the only way you can find the common ratio. So let us find now the rest. I can erase this part. Let's hope you have pause the video and copy the notes. Okay. Let's see how we can work out this side. I don't want to have to put that. So this is the last part of geometric progression. Okay, so now let's see what do we need to, what are we finding now? What are we finding? We are actually finding the first term. At least we know the common ratio, which is 1 over 2. Now we need to find the first term. So how do I get to find the first term? Using the same formula, I'm going to say, now find the first term, a is equal to a r n minus 1. We need to find the first term for this one. So, for you to find the first term, you know the common ratio, and you know at least the third and the fourth term. You know the fifth term. You know this one. So, you can use them to find the first term. Use whichever you want. So, I have, I need to find the fifth term. So, we are going to say the fifth term. I need to find the fifth. So, I know the fifth term. So, first term I don't know. Common ratio is 1 over 2. Then I have 5 minus 1 because I want to find the fifth term. It's more like I want to find, I know the fifth term, so I'm going to use the fifth term to find the first term. Okay? Or if I want, I can use the third term to find the first term because I know the third term. So in this scenario, what is my fifth term? My fifth term is 4. I replace with 4. Then my first term I don't know. I leave it the way it is. Then I can work out this side, which is 5 minus 1, it is 4. You write your 4 there. So everything inside the brackets, if it's written like this, it is raised to power 4. 1 is raised to power 4 and 2 is raised to power 4. So how do we work out this one? So we are saying 4 is equal to first term. 1 times 4, it is 1 over, okay, 2 times 2 to the power 4, 2 to the power 4, that is 16. 16, we have what? 16 there. We have simplified this part, which gives us 1 over 16. Now we need to get rid of this 16, 1 over 16, so that we have our first term. So how do we get rid of this one? We are going to multiply both sides by 16. Okay, the reciprocal of this one is 1 over 16. So we multiply both sides. This side we are going to multiply it by 16. Okay, and this side we are going to multiply this side by what? 16 as well. So when you multiply by 16 on both sides, then it's more like you are getting rid of this part which is here. So how do we, what will be our answer here? 1 times 16, it is 16. So we have 16 times 4. 16 times 4, we have what? 56. So we have 56 there, equal to A1, which is, of course, this will be A, 16 over 16, and you can see this is 1. So my first term, therefore, first term is equal to 56. That is my first term. You have found your first term. So your first term is 56. So now that you know what your first term is, therefore you can go ahead and find what will be the, what will be now, what is it, what are we talking about? Find the 10th term, find the whatever term, sum to infinity. It will be easy for you now to find because you know the first term. Okay, you know the first term. So 16 by 4, we have, why did I put 56? Now, if you use your calculator, you're going to discover that you get your correct answer. It's not 56 here, but it is 64. 64. 64. Okay. This is 64. 64. So the first term is 64. So let us go ahead now and find the 10th term and the sum to infinity. Okay. So the 10th term, we are going to find it here, which is of 2, of course. We want to find the 10th term, so we are going to use the formula an is equal to a term 1 r minus 1. So the 10th term, the first term is 64. Common ratio, it is 1 over 2. And what are the now here's what we need to, we have to find the 10th term, right? But how many terms that they have given us there? 10th, find the 10th term. Okay. So what will be my 10th term now? We are going to say 9 minus 1 there. Oh, 10, I mean 10 minus 1. So a 10th term is equal to 64. Then we are going to say 1 over 2 to the power 9. 1 over 2 to the power 9. Then we simplify that part by simply saying 64, 1 to the power 9, it is 1. 2 to the power 9, what is 2 to the power 9? That is 512. Then 64 by 1, 64 divided by 512. So we have our answer to be divided by 64. We have our answer to be 1 over 8. So the 10th term for this geometric progression, therefore, 10th term, the 10th term is equal to 1 over 8. That's the 10th term. You have found the 10th term like that. If you do it like that, my dear friends, then you have nothing to worry about. Because now, once you know your first term and the common ratio, the rest of the things become easy. But if you don't know the first term and the common ratio, things become tough. So you need to know those things first. Okay, so once we are done with that, now we can find the sum to infinity. Sum to infinity. So I can erase this part now. We can go ahead and find the sum to infinity. So how do I get to find the sum to infinity? I write the formula. So the sum to infinity, question 2, Roman numeral 3. Sum to infinity is going to be formula first term over 1 minus common ratio. So what is my first term? My first term is 64. What is my common ratio? 1 over 2. Now that you have a calculator, this becomes easy for you because a calculator should make things work out questions very quickly. So what is 64? We have when you simplify this part, it's more like you're saying 1 minus 0.5. The answer should be 0.5. You see that? So it's more like I'm going to multiply now. It will be 64 divided by 1 over 2. And this one we are multiplying 64 by 2. In other words, we are saying 64 divided by 1 over 2. Hence now we are saying 64 times 2. Now here I'm not using a calculator. I've just shown you how you can write. So 64, what will be our final answer? Bring it there. 64, use a calculator. 64 times 2, what do we have? 128. 128. Therefore, sum, or you can just write, don't write sum. Just say, therefore, sum to infinity is equal to 128. That is how you work out this one. Sum to infinity is equal to what? 128. That is how you find this question. As you can see, it has taken us a long time to answer this question too, because this is how question come in geometric progression. Now the next video, it will be of this kind of questions. Very complicated ones. Now, if you miss the next video, then it means that you are going to miss out 7 marks of your grade 12 examination. Now, this gives you 7 marks, grade 11 work. Hopefully, I've made this clear. Pause the video, copy the notes in your mathematics books, and attempt it to solve it. Remember, mathematics is everyday practice. So, practice on this daily. Find past papers. You can use the app to get ECZ past papers and be able to solve questions of this kind. When you are stuck, when you have a question, do comment on the commentary box so that I can easily reply to you. And if I've made this lesson easy for you, please just like the video and share it with your friends so that I get to know. If you don't say anything, I assume that everything is complicated. So please do as I have asked and do subscribe so that you don't miss every time I post a new video, you get to be alert you get to know what is happening. Otherwise, this is how we work out this question and we are done with geometric progression. The next thing we shall look at now is ECZ examination questions. That's all. How they come, and we shall solve 2 or 3 past papers of questions and we shall be done with this lesson. As for now, we end from here. Have a calculator and use it effectively. God bless and see you in the next lesson video. I love you all. Bye-bye. Peace.